Welcome to a new lesson. In this lesson, we'll be discussing the general form of the equation for a linear relation. Before we do this, let us review some equation forms. So the first equation form is called the slope y-intercept form. Recall that the coefficient in front of the x is the slope, while the -4 in this case, for example, is the y-intercept. Now the next form is the slope point form, where 2/3 is the slope again, and the point that's on this graph is referred to as 3 and -2. Recall that we're always taking the opposite values for our x and y coordinate. Another form of this equation is called the standard form, where we have x and y on one side of the equation and the constant number, in this case 12, on the other side of the equation. And what we're going to focus on today is the general form, where we have the x and y on one side of the equation as well as a -12 on the other, which is equivalent to 0. That's called the general form. Believe it or not, all these equations have different forms, but all of these equations draw the same line. Therefore, they're pretty much the same equation. Let's take a look at an example. In this example, we'll rewrite an equation in general form. So A is in slope y-intercept form, and we're going to rewrite it in a general form. The general form refers to as having a coefficient times x plus another coefficient times y plus the constant, and that's equal to 0. So that is the general form equation. So how do we change this into, how do we change y equals -2/3 x plus 4 into a general form? The way we do it is we recognize that there's a 3 as a coefficient, as 1/3 as a coefficient in front of the x. It is a fraction. So we're not going to have fractions. A, B, C's, all of these values, they have to be integers. An integer are whole numbers, positive or negative. Usually A is a positive integer. So they have to be integers. So we have to eliminate the fractions. The way we eliminate the fractions is that we multiply each and every term in this equation by 3. When we do this, the 3's will cancel, and we have no more fractions. We'll get 3y on the left-hand side, -2x, because the 3's canceled with each other, plus 4 times 3, which is 12. Then what we're going to do is we're going to move the 2x over to the left-hand side by adding it to the equation, as well as subtracting the 12 to get rid of the 12 from the right side of the equation. If we add 2x on one side, we have to add 2x to the other, and we also have to subtract 12 because we subtracted 12 from the other side of the equation. So overall, we get 2x plus 3y minus 12 is equal to 0. And this is the answer we're looking for. This is the general form for our equation. The next equation is point-slope form of an equation. And we're going to change that into a general form. We again do the same type of procedure. We recognize what the fraction is, the 5, and we multiply everything on the right side, or every term, by 5 in the equation. When we do this, the fraction disappears. 5 divided by 5 is 1. And on the left-hand side, we get 5y minus 5. 5 times y is 5y, and -1 times 5 is -5. On the right-hand side, we get 3 times x plus 2, x plus 2 in brackets. We're going to expand this, and then we're going to move everything to the one side of the equation. So when we expand it, we multiply everything that's outside the bracket to everything that's inside the bracket. Then we copy 5y minus 5. 3 times x is 3x, and 3 times 2 is 6, positive 6. Then we're going to move everything one side of the equation to the next. Now, in this situation, I'm going to move everything to the right side of the equation. I'll explain to you in a second why I did that. In order to do that, we're going to subtract 5y from both sides of the equation. and add 5 to both sides of the equation. We do this because 5y minus 5y is 0, and negative 5 plus 5 is also 0. So therefore, on the left-hand side, we get 0, and on the right side, we get 3x minus 5y, and 6 plus 5 is 11. And this is a general form as well. The only difference between these two equations is that the 0 is on the left-hand side versus on the right-hand side of the equation. And if you don't know what left-hand side is, well, that's left-hand side of the equation, and this is the right side of the equation. Now, for our general form, it doesn't matter where the 0 is. It's either on the left or the right. Let's move on to the next example. In this example, we're going to determine the x and y intercept of a line whose equation is 3x plus 2y minus 18 equals 0. We're going to graph it, and then we're going to verify that the graph is correct. So first, we're going to find the x-intercept and the y-intercept of 3x plus 2y is equal to minus 18 is equal to 0. Now, this is in general form already. Recall that whenever we have an x-intercept, the y is equal to 0. So we're going to plug in y equals 0 into this equation, and we're going to solve for x. So 3x plus 2 times 0 minus 18 equals 0. 3x plus 0 minus 18, we're going to subtract 18 from both sides. Actually, plus 18 from both sides. And we'll get 3x is equivalent to 18. Now, there's operation and multiplication between 3 and x. So we're going to divide both sides of the equation by 3 to cancel out this 3. And we get x is equal to 6. 18 divided by 3 is 6. This means that this 6 is our x, my x-intercept. For a y-intercept, we know that the value of x is going to be 0. And now in our equation, we're going to put in the value of x to be 0, and we're going to solve for y. 3 times 0 is 0. Now we're going to again add 18 to both sides of the equation. So on the left-hand side, we have 2 times y is equal to positive 18, and then we divide by 2 both sides of the equation to cancel out the 2, and y will equal to 9. So this means that the x-intercept, the y-intercept is going to be 9. And we recall that whenever we have a y-intercept, x equals to 0. Now let's graph this line. So the x-intercept was at 0, 9. The x-intercept was at 6 and 0. So 1, 2, 3, 4, 5, 6. And it appears to be right here. 6 and 0. 6 and 0. The y-intercept was at 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here at 0 and 9. And the line would be going through 0, 9, and 6 and 0. Here's the line. Then the last thing is we have to verify that the graph is correct. Now, let's pick from the graph a point. Let's pick 2 and 6 right here. This point appears to have a coordinate of 2 and 6. Now, if this equation and the graph match, 2 and 6 should satisfy the equation. What does that mean exactly? This means that if we put in value of x to be 2 and value of 6 for y, then the equation should equal to 0. So we're going to do that. We're going to have 3 times 2 for the x value. We're going to add 2 times 6. We're going to subtract 18, and we're going to see if it equals to 0. Question mark. This is the left side of the equation, and 0 is the right side of the equation. So 3 times 2 is 6, 2 times 6 is 12, and it's minus 18. What happens if we add them up? You get 0. Since the right side of the equation is also 0, the point 2 and 6 lies on this graph. And since it lies on the graph and satisfies our equation, this means that the graph is correct. Let's take a look at yet another example. Determine the slope of the line with this equation. Now this is a general equation, 3x minus 2y minus 16 equals to 0. It's general. We can't just look at this equation and tell exactly what the slope is. So what we have to do in this situation, we're going to have to convert this equation into slope y-intercept form. So recall, how do we do that? Well, we're going to move the y to one side and everything else to the other side. So we're going to add 2y to both sides of the equation. That means the 2y's will cancel, and on the left-hand side of the equation we'll get 3x minus 16, and on the right side of the equation we'll get 2y. And since there's an operation of multiplication between 2 and y, we're going to divide each term by 2. So on the left-hand side, we'll get 3x over 2, minus 16 divided by 2 is 8, and on the right-hand side of the equation, 2 is canceled out, and we get y. Now recall with this form of the equation is that 3.5, or 3/2, is the slope, while the 8, it's funny looking 8, is the y-intercept. And since the question is asking for the slope is 3/2. And our last example. In this example, we'll determine an equation from a graph of generated data. So peanuts cost $2 per 100 grams, and raisin costs $1 per 100 grams. Devin has $10 to purchase both these items. We're going to generate some data from this relation. We're going to graph the data. We're going to write an equation for this relation in general form. And then we're going to answer some questions using the graph. Since we're generating some data, it's probably a good idea to have some type of a table. Let's take a look at the peanuts cost. It costs $2 for 100 grams, and for raisins it costs $1 per 100 grams. Now, we have $10 to spend. Let's say we are only going to be purchasing peanuts. So since we have $2 and 10 divided by 2 is 5, we get 5 100-gram bags of peanuts. Again, how do we do that? 10 divided by 2 is 5, and 5 times 100 is 500 grams. And since we have 500 grams for peanuts, we'll get 0 for raisins. Now, suppose we're getting only the raisins. Since we have $10 to spend, 10 divided by 1, because $10 over 1 is 10, so we could have 10 bags of 100 grams, which is 1,000 grams, or 1 kilogram. So 1,000 grams of raisins we could purchase if we get no peanuts. So these are the two type of information that we could get. We could also get other data points, such as, well, we could get, for example, arbitrarily, we can get, let's say, 2 bags of 100 grams, so we could spend $4 on peanuts, and that will give us 200 grams. And then we have to spend $6 on raisins, and that's 600 grams for raisins because it's $1 each at 100 grams per bag. So we could use that also information as our data. And using these 3 points, we can plot these points on our graph on the right-hand side when we have raisins and peanuts in grams. Okay, now let's plot these values in. So we have 500 grams of peanuts and 0 raisins. And here is the point. So we have peanuts on the x-axis and the raisins on the y-axis. 0 and 1,000, so 0 peanuts and 1,000 grams of raisins. Here's your point. And then we also have 200 grams of peanuts and 600 grams of raisins. We have 3 points. We're going to use a line to connect these 3 points. Of course, you should be using a ruler when you are drawing a straight line. It's hard for me to do it on this iPad. So here is our graph. The next part is that we are going to write an equation to express this as a general form. We're going to use the graph to help us find out what the equation should look like. So let's find the slope first. So the slope is going to be, this is the rise. So we're going down by 1,000, and the run is 500. So remember, slope is rise over run, which is 1,000 minus over 500. Because we're going down, the slope is -2. Also, we know the y-intercept of it. The y-intercept is 1,000. So our equation will be y is equal to -2x plus 1,000. Now, what does the x and y represent? The y in this case represent the raisins. And the x represents the peanuts. In other words, we could write r is equal to -2 p plus 1,000, just to represent the specific raisins and peanuts. This is not written in general form. We have to move all the variables to the left-hand side of the equation for general form. So we're going to add 2p and subtract 1,000 from both sides of the equation. So on the left-hand side, we will get 2p plus r minus 1,000 is equal to 0. And this is our general form. So this should answer part C. Now let's answer part D. Will Devin spend exactly $10 if she buys 300 grams of peanuts and 400 grams of raisins? And will Devin spend exactly $10 if she buys $4 grams, 400 grams of peanuts and 300 grams of raisins? I'm going to use the graph and the equation to justify the answer. In this case, let's erase everything and just have 2p plus r minus 1,000 equals 0. Now, if Devin spends exactly $10, then the 300 grams of peanuts and the 400 grams of raisins have to fit on the green line, on the equation of the green line, as well as inside the equation. So let's plug in those values to see that it works. So the value of p in this case is 300. And now the value for r, which is raisins, is 400. If we subtract 1,000, they should give us the value of 0. So that is the left side of the equation. And the right side of the equation, rs, should be 0. So 600 plus 400 minus 1,000 is minus 1,000 is 0. So the left side of the equation equals the right side of the equation, and this means that exactly to spend $10, 300 grams of peanuts and 400 grams of raisins have to be purchased. Now, on the graph, this 300 grams and 400 grams have to be on the green line. So let's take a look at the points. 300 grams and 400 grams of 300 grams of peanuts and 400 grams of raisins are approximately here. Oh, they do fit. So peanuts is 300 and raisins is 400. They do fit the graph. What about part II? So in this case, the peanut value is 400 grams and the raisin value is 300 grams. So we'll take those values in and put them into our P, subtract by 1,000, and we'll see if that is equal to 0. So now the peanut is 400, the raisin is 300, so 2 times 800, 400 is 800, plus 300 minus 1,000, that is equivalent to 100. It does not equal to the 0. This means that you cannot purchase 400 grams of peanuts and 300 grams of raisins to get $10 and spend $10. Let's take a look at the green line. Where does this 400 and 300 fit on our line? Or if it doesn't. My guess is that it doesn't. So if I look at this point right here, it's 400 and 300. It doesn't fit on the line. It doesn't fit on the line and doesn't fit in our equation. Therefore, you cannot purchase 400 grams of peanuts and 300 grams of raisins for $10.